Hi guys, welcome back. Let's go ahead and write down today's objective. Today's objective is I can identify each function family. Okay? Now we're going to start off these notes by playing What's My Rule. I'm going to help you remember how to play What's My Rule by doing number 1 with you. And then you guys are going to do B and C. All right, so for letter A, not number 1, letter A, we have to identify the number that goes after the x and the number that goes before the x. Now, over here, we have f of x, which you guys know is y. Now, the number that comes after the x depends on the input of 0, and we can see the input of 0 is a 1. So we're going to put plus 1 afterwards. And then the number that goes out in front depends on the change in the y, and then we're going to divide by the change in the x. So you can see that the change in the y is adding 3 each time. And then if you look on the other side, the change in y is adding 1 each time. Oh, sorry, the change in x is adding 1 each time. So the number that goes out in front of x is the change in y divided by the change in x, which in this case is 3 over 1. All right, so this right here is the rule for A. Now go ahead and do B and C on your own, and then we'll go over it. All right, now for B, what we're looking at is the input of 0. That gives me an output of 2, so we're going to have x plus 2. Now we got to find out what goes out in front of the x. So what we need to do is find the change in y and divide by the change in x. And this time the change in y, we're adding 2 each time. All right. And then on the other side, we're adding 3 each time. All right. So what that means is the change in y divided by the change in x is going to be 2 over 3. So the function rule is f of x equals 2 over 3x plus 2. All right, letter C, we're going to go ahead and do that one. So the input of 0 gets me an output of 2 again, so it's going to be x plus 2. We're going to find out what goes out in front of the x. So we can see that over here we're decreasing by 3 each time. And then on the other side, we're increasing by 4. So each time you go up by 4. This gives me a rate of 3 over 4. That's what goes out. Excuse me, guys. Sorry about that. That's what goes out in front of the x over here. So this is the rule for C. Now, it says right here, what do you notice about the rate of change for these functions? Well, in all these rates of change, you can see that we're going up or down by the same number each time. So in B, we're going up by 2, up by 3. In C, we're going down by 3, up by 4. So what we're going to say is that this is a constant rate of change. So let's go ahead and write that down. Constant rate. Okay, it's a constant rate of change because each time we keep going up or down by the same number. Now what we're going to do is we're going to graph these points over here. I'm going to do the first one with you guys. So let's change the color on this. All right, so for A, this first point right here is -2, -5. So that's down into the third quadrant right here. Then we have -1, -2. That's still in the third quadrant because they're both negative. -1, -2 is right there. All right, then the next point is 0, 1. That's on the y-axis. Because x is 0, you know it's on the y-axis. And then the next one is in the first quadrant because they're both positive, which is 1, 4. Then we're going to connect the dots, and you can see that we have this shape right here. Okay? Now what I need you guys to do is I need you to plot the points for B and C, and then what I need you to do is down here, you have to tell me what do you notice about these graphs. Okay, go ahead and do that right now. All right, now for B, let's go ahead and plot these points really quick. So the first one is -6, -2. So that's over here. The next one is -3, 0. Then we have 0, 2. Then we have 3, 4. Okay, so you connect these just like that. All right, and then the last one we have -4, +5. So that's in the second quadrant up here. Then we have 0, 2. That's right here. Then we have 4, -1. And then the last one's going to be on the graph. If you did draw it, it would look like it's somewhere around here, okay, which is 8, -4. So let's go ahead and connect the dots. And then hopefully you guys noticed that all these graphs are lines, okay? And because they're lines, they have a special name. It says we call these kinds of functions linear, all right? Now let's go down to the next part of this. All right, so now looking over here, you can identify if something is a linear function by 3 different ways, okay? You can identify it by looking at the graph. So if you see that we have a line, it's automatically going to be linear, all right? So you can so you can tell from the graph. Oopsie, I should have put graph in there. Let me erase that. And then you can tell by the graph because it needs to be a line. If it's a line, it's linear. You can also tell by the equation or the rule or the function, right? Now, if you look at all these rules up here, all right, you can kind of see that each of them have something in common. The thing that they have in common is that they all have x to the 1 power, okay? So let's go ahead and write that down at the bottom. So in the rule, if you have x to the 1 power, it is linear. All right? And then the last thing, we determined it from the top by looking at the chart or the table, okay? And because we increased by a constant rate of change, so over here we add 2, on the other side we add 1, all right? That tells me that we have a constant rate of change. So if it's a constant rate, it is linear. So those are the 3 ways, okay? So if it's a line, if it has x to the 1 power, or if the chart has a constant rate. All right, now we're going to look at a new function family. So here we go in the next family. So now for this next family, you can see that the rate of change is not constant, because over here, the first one, what's happening is you're subtracting 3, then you subtract 1, but then you add 1, and you add 3 again, okay? So looking over here, it's pretty much the same thing, but in reverse. We first start out by adding 3, then we add 1, then we subtract 1, then we subtract 3. So what's happening to the rate of change? What I usually tell my students to do is they notice that it increases, all right, and it also decreases, okay? So that's always going to happen in this specific family, all right? Now, over here, what we're going to do is I'm just going to go ahead and give you the function family because, again, this is kind of hard. This right here, seeing that it decreases and increases by different numbers each time, I'm just going to give you the rule. So the rule for number 1 is x squared. So anytime you plug in an x value and square it, you wind up with the y value, the output. So 0 squared is 0, okay? -2 squared is 4, all right? Over here, this one you're doing actually a couple things. You start out by subtracting x squared, or taking the opposite of x squared, and then in this one we're adding 1, okay? Now, you will not be asked to find the rule of something that's from this family. The only rule that you would be asked to find is something that's in the linear family. Now, what I want you guys to do now is I want you to graph these points. So graph these 5 points right here, all right? And graph, let's change the color. Graph these 5 points into this box. Graph these 5 points into this box, and then tell me what you notice. Go ahead and do that right now. Alright, so let's go ahead and graph these. Alright, now for the first one we have negative 2, positive 4. We have negative 1, positive 1, 0, 0, so we're at the origin. And then we have this one, 1, 1, and then 1, 4. So it's going to connect like this and then go back up. Alright? Now for the next one, we're going to have negative 2, negative 3, so we're in the third quadrant. Negative 1, 0, we're on the x-axis. Then we have 0, 1, then 1, 0, and then we have 2, negative 3. And this is what this graph looks like. Now I gave you a choice to pick from, and the best choice for this was U or upside down U. Okay? So it's a U or an upside down U. Now, this function family, let me go ahead and give you the name of this function family right now. This is called the quadratic function family. Okay? Now, you can identify, just like you can identify the linears by 3 different methods, you can also identify the quadratics by 3 different methods. Now, looking at the graphing method, when you're looking at the graph, if you see a U shape or an upside down U shape, you know that it's quadratic. Okay? Alright, now looking at the equation, now let's take a look at the equations up here. I'm going to give you a chance to kind of guess what do you notice about this equation and this equation that'll help you know that it's quadratic. Go ahead and try to figure it out right now. Alright, hopefully you got this correct. Let me go back down there. So, how do you know? By looking at the rule or the equation. You will know by seeing the x squared. Okay? So if you see x squared, it's automatically quadratic. Alright? Now, about 3 years ago, some of my students came up with this little rhyme, and it helps because it helps you guys remember specifically these kind of problems right here. If let's just write this down for you. If the exponent is 2, it looks like a U. Okay? And we already identified this part right here for the chart. We know that it's going to have increasing and decreasing numbers. Okay, so just like we saw up here, it's going to go down then up, okay, or it's going to go up then down. All right, let's go to the next function family. Hey guys, so now on the third, in the third function family, this one is again a different function family. So you can see in the chart right here, what's happening is we are multiplying by 3 each time, okay? Because 1/9 times 3 is 1/3, 1/3 times 3 is 1, 1 times 3 is 3, and then 3 times 3 is 9. So each time we're increasing by multiplying by 3 each time, okay? On the other side, you can see that we are dividing by 2 each time. So 4 divided by 2 is 2, 2 divided by 2 is 1, 1 divided by 2 is 1/2, and then 1/2 divided by 2 is 1/4. Okay? Now, some people argue that this is a constant rate of change, but it's not, because if you look over here, these are not increasing by the same number each time. What's happening is they're being multiplied or divided each time. So what we're going to say is multiply or divide each time. That's the rate of change. Okay? Now again, the function rule is going to be hard to kind of figure out, so I'm going to go ahead and help you out with this one. For this one right here, you're going to get 3 to the x power. So these numbers would go in for x. So 3 to the 1 power would get you 3. 3 to the second power would get you 9. 3 to the 0 power would get you 1. All right. Over here, this one is a fraction, which is 1 over 2, that's being raised to the x power. All right. So now graphing is going to be kind of tricky, so I'm going to help you graph the fractions. So for a, the first number is -2 and then 1/9. That's pretty close to the x-axis. Then 1/3 is also pretty close to the x-axis. All right. So here's 1/3. Then we have, let me move back up. All right. Then we have 0, 1. Then we have 1, 3. And then we have 2, 9, which is probably going to be somewhere up here. So the graph is going to look something like this. Okay? Now I want you guys to graph B and then tell me what you think that the graph looks like. Go ahead and do that. Alright, so for graph B, it's going to look just like this. We have -2, +4. We have -1, +2, 0, 1, 1, 1/2, and then 2, 1/4. So this is what this graph is going to look like. Okay? So what I usually say when I see these functions, I call them the L's and J's, because that's what they always look like. They either look like an L or they'll look like a J. All right. Now let me go ahead and give you the name of this function family. This function family is called the exponential family. Okay. Now again, there's 3 different ways that you can identify if something is exponential. All right. The first one is the graph. Now again, the graph is either going to look like an L or a J. So this is what the J looks like, and then this is what the L looks like. Okay? So if you see any of those graphs, then you know that it is exponential. If you look at the equations, well, let's go back up to the equations and see what you notice. All right? So take a look. What do you guys see that would make these graphs, these equations tell you that it's going to be exponential? Go ahead and try to figure that out. Okay, so what makes it exponential? Well, again, looking at the rule or the equation, if the exponent is x, it is exponential. Okay? Now, again, we already set it up there, but the way that you look at it from the chart is if you multiply or divide each time.